What's up, guys? I'm catching up on the weekend's advent of code, starting with day 9, Mirage maintenance. We've got these sensors in the desert picking up different values, maybe temperature, humidity, things like that. And each line is a single value changing over time. Our job is to predict the next one, which in this first line is easy because 0, 3, 6, 9, 12, 15, we know it's going to be 18. They just go up by 3 every time. Others are not so easy. They see it speeds up or slows down or maybe even turns around and goes backwards for a while. You could imagine different graphs in math class, maybe going straight up or straight across or wiggling back and forth. And how do we predict? We find the rate of change. If it's constant, like in the first one it was 3 every time, we're good. If it's not, we take the rate of change of that. And if it's not constant, we take the rate of change of that. Kind of like if you started with position, you could find the velocity, and from there you could find the acceleration, and from there you could find whatever's next. I think it's called jerk, and so on until you found something constant. And really they go one step further until you get all zeros. So they give us a nice visual here. We have the list, and then the 3s, and then the zeros, which means we're good. Sometimes it takes longer, like this one. They're speeding up, they're still speeding up, but then finally it's constant, and we know for sure because we hit the zeros. And either way, however long it takes, you rack up all the edges, the rightmost ones, to give you the prediction on your top list, okay? And then you do that for all the lists, which in this case was 3 different ones, and you add up those, the 68 and the 28 and that original 18 that we predicted. So let's do it. In here I have the data, which is long but still the same thing, and I have those test data lines. So let's write the parsing first to get the numbers, and then we can use them, because right now it's a string, which is not very nice. So it's going to take some lines, and then it's going to return, we're going to make an integer for x in, let's just say L for the line, and this is going to handle them all at the same time, so we'll go for L in lines. Now let's print that to make sure we did it right. We'll do the test, but I forgot to put dot split. There you go. That's why we test it, because I wouldn't want to run into this error at the end. I'd want to find it now. So we got a list of numbers. We got a list of numbers. There's no quotes anymore. They're ready to do the addition or whatever we need. Okay. And in some of my advent of code problems earlier, I would do that inside of the same function that figures out all the work. But in this case, spoiler, it's going to be a recursive function. So I wouldn't want to hand it a string the first time and then numbers all the other times. It would get kind of complicated. I'll parse it beforehand and give it the numbers in the first place. So our part 1 is going to be like, we go the sum, because we're adding up all these extra ones, of extrapolate. That's what they call the process of finding the next thing. We could use the word next, but there's already a function in Python called next, and I've actually used it in some of these advent of code, so we don't want to step on its toes just in case. And then we do, we'll call it L for line, for L in lines. Okay? So extrapolate is obviously the work that we have to do, but this is, we're finding the next one for all the lines and adding up the results. Okay? Or I have to say parse lines because we don't want to give it a string. Or we wouldn't even be able to pop that string open the same way. So now let's do the extrapolate, which takes, I don't want to say line because this is a list of integers, and earlier when we said line, that was a string, so I don't want to use the same name for different things. We'll call it nums because it's getting numbers like we had in our parse a minute ago. So this is going to be a recursive function. We're going to do some work, find the new list. If it's ready, then we add up all of our stuff. If not, we put it back through the same function again. And whenever you do that, it's exactly the same as a while loop. You need two things. One, how do we do one step? And two, how do we know when we're done? So let's say the how do we know when we're done part first. That's often kind of simple. We'll say if they're all 0, right? If all x is 0 for x in nums, we're done. I could also say not any nums, because 0 counts as false. If you say not any, that means, you know, they're all 0. But that's a little weird. It's hard to read for people who aren't expecting that. So let's say sum of what? Sum of history. I'm going to use the word history to be like those ones that were lit up on the side, like you're racking up all the rightmost ones. And I'm going to call that history, because that's a word that they use in their description. Obviously, it doesn't exist yet. And since this is recursive, we're going to pass it along into the function every time. And the first time, it'll just be none. So we'll say, if history is none, we'll start it out with our, I guess it would be like the last one of the row. Like, so what's going on is we're gonna travel down, build all these, and then add up as we go. So it's really not the lit up ones, it's like the one next to it. It's like the 45 and the 15 and whatever, that gets you the 68. And the way we're gonna do that is starting with the last character, I guess it needs to be like that, of the first line. And the reason I can't just put empty list is that lists are mutable, and so if you put them as a default, it's the same one forever. It's not a new list whenever you call it again, and that would mess it up. So anyway, now we finally got all the setup ready and we can do the work. The work is to find the differences. Like if we have these, we find the difference between here and here is 3, here and here is 3, here and here is 5, and so on. And the way to line that up, I'll say diffs equals b minus a for a, b, in. The way to line that up is called pairwise. Okay, if I could type it pairwise nums, that's a function that gives you like 0 and 1, 1 and 2, 2 and 3, 3 and 4. We have to import it from itertools. But if we couldn't, if we had to make our own, that's fine. We'd just say like AB for AB in zip nums, comma, nums 1 to the end, because that's like the list, and then the list offset a little bit so that each guy is next to his neighbor. But we don't have to. Pairwise is already there, and it's a little bit better than that. It doesn't take as much memory as copying the whole list. So there you go. And then if you have that, you can take the last one of those and put it in your history. And we only care about the last one. We don't actually need to keep track of every single one and every single step. We only need to remember like the 45 plus the 15 plus the 6 plus the 2 plus the 0 if we have to, and then unroll them all the way back. So we don't need to remember the history of every single one every time, but we do use it now, so we need to say like extrapolate of diffs. We're sending back the new version through the same function, and the history, because we're remembering it, and we can append to it as we go. I think that might actually be good. Let's print part 1 of the test, and that should have been 114. So it's 68, 28, 18, 114. Is that going to work? I don't know. Hey, it is 114. Great. So now let's do the big data. Hey, it's a big number. Is that 2161? Hey, that was the right answer when I did this earlier. So just to illustrate, let's do it with the test again and have it print along the way. So this will show like those steps like they showed. So this is like, okay, we have these, and then we have the differences, and they're constant, so we hit the zeros. We have these, and it's still speeding up, but now it's constant, and we hit the zeros. We hit these, and it's speeding up, and it's still speeding up, but eventually it flattens out. So that's what it does every time with just bigger numbers and bigger lists. Now, part 2 says, what if you go the other way? You extrapolate to the left and see what happened before the machine was collecting data. And when I did this earlier, I came up with this whole new thing, and it looked at the left, and it used like reduce function. But then I realized you can just reverse the lines. So you can just flip the lines and do the same extrapolate as before to find the new right, which is the old left. And of course, they're a lot smaller numbers because they're going the other way, so they're small, sometimes negative. So the answer is not that bad. So let me show you what I'm talking about. Def part 2 will return the sum. It's still the sum of extrapolate L, and then I just added a parameter, reverse equals true, for L and parse lines. I guess we could do it on the parse and have them spit out the reversed version, but I put it in here instead. So we're going to add a reverse equals true to the function to say, hey, if, or no, false is the default. If you're doing it like you did before, no problem, keep it. But if we tell you to reverse, you're going to do a tiny bit different and find a new answer. Okay, so basically we need to say the first time we reverse it. The other times we don't want to flip back and forth every time, right? Just the first time. So we'll do it in here, and that's pretty much it. So we're going to say like if reverse you know, nums equals nums default start and stop. -1 means go the other way, so that's a reverse. And I think that's kind of it. I think that's all we need. If you put reverse in the middle, then you have to add it in here, which is why I put it on the right, so we can keep this simple. So let's go on the test with the part 2, and it's still going to be printing along the way. Is that the right answer? It was 2, okay. So now let's do it on the big data, see if that's enough. And 1091, yes, and it is printing every single one, which is ridiculous and slowing us down. But that was a great problem, because if you set it up a certain way, then boom, you just add a tiny, tiny bit to get the new answer. You could, like, when I did this earlier, I added a new function. It was called extrapolate left, and it was pretty much the same, except you grab the left, and you grab the left, and you put a new thing in here, and it's all like mixing it up. And then you couldn't do sum, you'd have to like minus, and that was a whole issue. But you could just flip the lines, and that works. And Python already gives us a nice way to do that. You could say reversed. There's a function called reversed, but it doesn't give you a list. It gives you like a lazily evaluated object that can't be indexed. So this is just shorter, and it works just as well. So that's great. Maybe I'll do 2 today or 2 the next day, trying to catch up, especially if they're as easy as this.